And speaking about augmenting humans, I certainly could use a little bit of that today. We've got Ben Tran. Ben Tran has been thinking deeply about this for many years now. Been a super partner along the way from his great work in the Strategic Capabilities Office, now a fellow Air Force Research Laboratory. Ben, tell us about autonomy and where you think we might be able to come up with an autonomous prime to prime the market. Thanks for joining us.
Yeah, hey Vidoff, good to see your face. It's been a while, but and thank you for inviting me to talk about such an exciting topic here. You've got a lot of them today, and I've really enjoyed hearing about some of the other primes. Again, my name's Ben Tran. I'm a branch chief for the Multi-Domain Sensing Autonomy Division. That's part of the Sensors Directorate at Wright-Patterson Air Force Base in Dayton, Ohio. And as Colonel Diller mentioned, I'm here today to talk with you about autonomous prime and kind of introduce the topic as a prime for AFWERX. And what I'd really like to do is start off by giving you a definition for autonomy from a military perspective. As many of you who work with autonomy or have heard of autonomy or familiar with it, it can be used in many different contexts and have many different meanings depending on an individual's interpretation of the word. So we really try to keep everybody on the same page with a common definition, and you'll hear this again tomorrow from a colleague of mine, JC Leday, who will be leading the autonomous prime section of the Design a Prime workshop that will start at about 12:45 p.m. Eastern tomorrow. So we're really looking forward to engaging with industry on that. So I really hope that everybody that is dialed in today will dial in tomorrow to talk with JC and I about autonomy. So back to the definition, we define autonomy as the freedom to select a course of action required to achieve a higher authority's objectives. And we split up autonomy into two different categories in the Air Force. We talk about autonomy at rest. So Colonel Diller earlier, when he was talking about the autonomy prime, he mentioned like digital infrastructure and PINs, which stands for public infrastructure network nodes, and how we're leveraging Internet of Things and 5G to enable autonomous things out there in the real world, not to include things that move, as well as things like your computer that are at rest. And we also refer to this autonomy at rest as a decision aid type of capability, where we have what we call predictive data analytics. So if you think about the Air Force and its mission, as well as the Space Force, we spend a lot of our time collecting information from space and from air. And we have all sorts of sensors out there in the world that are consistently collecting information, more information than we will ever have enough humans to look at. And so, with autonomy at rest, we are developing artificial intelligence and machine learning capabilities to conduct analysis of that vast amounts of information, so that we can use that data to inform the humans that are making decisions for our air and space forces. The second category that we have for autonomy, and that's the one that I'm personally most familiar with in my line of work, is autonomy in motion. And we refer to that as a closed loop capability for particularly unmanned systems. So if you're familiar with the Skyborg Vanguard, I would say that that's probably our most high visibility autonomy in motion program right now that's being run out of the Air Force Research Laboratory. We also talk about manned-unmanned teaming. And so if you have, a UAV or an unmanned system and flying in the air, how would we team that with, our fighters or our cargo aircraft, and what autonomy would be needed in order to enable that type of a capability? In addition, we talk about robotics and autopilots. As many of you already know, we have some pretty advanced autopilots in our manned platforms as well. And there's actually quite a bit of autonomy that's already implemented in those platforms, and we're looking to continue to advance the autonomy in our manned platforms as well. And then when it comes to robotics, one of the things you don't really think about a whole lot with the Air Force is what we do on the ground and what enables those platforms to continue flying in the air. So some other concepts that we've tossed around are just something as simple as an autonomous cargo loader. If you look at, what our Air Mobility Command does on a day-to-day basis, with loading aircraft with cargo and the logistics associated with that, there's a lot of opportunity there to introduce autonomy into the things that move with our Air Force that may not necessarily be flying. In addition to that, just expanding on the topic of autonomy for Air Force, we are looking at in all domains, so air, space, cyber, the entire electromagnetic spectrum, logistics, maintenance, sustainment, business operations, and the list goes on. I've said it once, I'll say it again, it's a broad technology area, and I'd like to spend the last few minutes of the time that I have here to focus a little bit on how we view autonomy and what that ecosystem looks like. So I'm going to try sharing my screen real quick here.
About 1 more minute, Ben.
Oh, okay. I'll try to fly through this real quick then. Is that working?
Looks great.
Okay, cool. So 1 minute. So when it comes to the ecosystem that we, the Air Force and Space Force, look at, is the technology that's required in order to implement autonomy into our systems. The primary tech areas that we're looking at are an open development environment. So if you're familiar with Platform 1, something like that, where we can have cloud-based regression testing and containerized SIL simulators, as well as access to quality and labeled data. We're also looking at lowering the cost of customization of both the software and hardware that enables our autonomy. We are looking at the safety and security of the autonomy itself, as well as assured autonomy, especially for those things that are moving in the air. We also believe in a progressive deployment of autonomy. And if you're familiar with Tesla's shadow testing, that is something that is of interest to us. And then we're also looking at autonomy for process improvement, and we can see the overlap with commercial there with increasing efficiencies, which would also increase profit and increase savings. We're looking at the goal of establishing this continuous development of artificial intelligence that would feed into all of that. And then I leave you with a quote from Will Roper, where the sky is the limit. And we're open to any and all ideas from industry, as well as our military men and women. And that's all I have. Thank you.